Hey there, Adam with Maniacal Labs again, and what you see before you is the Adafruit PiGrrl 2, spelled with two R's. I have no idea why, but whatever, it's cool. This is kind of one of those kits that I've eyed for a while. I think they had, well, obviously this is the 2, so they had another one before. Just always looked like a kind of fun little thing, especially just for the form factor that it is, and that it runs off of a full Raspberry Pi with all the capabilities that that brings. So I hadn't really ever wanted to pick it up because I've got enough projects as it is, but earlier in the year I was helping a good friend out with some projects of his own, and this appeared not long after. He got it for me just as a thank you for helping him out with all the LED stuff. So now I'm really excited to put it together. But so pretty much everything you see around here is, or around the 3D printed parts in the middle, is what actually comes with it, with the exception of the Raspberry Pi that I probably just pulled out of a drawer. Actually, I think I bought an extra one and then realized I had more that I hadn't already been using, but I buy Raspberry Pis like candy. So everything else comes with the kit, with the exception of the battery pack, which also was just, I had pre-existing stock of that. You can use as small as I think 1200 milliamp hour. This is a 2500, but the instructions recommend using one like this. This is a little bit smaller than what you'd find in an average cell phone. So I'm going to guess the battery life on this is probably only going to be a handful of hours. I don't honestly remember what the original Game Boy was, but you know, it's got charging and everything built in, so that shouldn't be much of a problem. Although, Raspberry Pi Foundation, please put an actual hardware reboot and shutdown button on your devices, because that would be amazing. Because I'm realizing that I probably have to like shut it down in software and then turn it off. Otherwise, I'm going to corrupt the SD card. So that'll be interesting. But yeah, so the parts that are 3D printed here are obviously the case. So this was kind of turned out really cool. This is printed in PETG, which is a little bit new for me. This is actually the first real functional thing I've made aside from the standard, calibration cube and benchy, which all came out really nice. I printed these on my new Formbot T-Rex 2 Plus, and yeah, it's a little bit harder than PLA. Harder to print, not harder in terms of material properties. It's actually pretty sort of flexible for what it is. It's definitely better than trying to print ABS, but it still was a little bit of a pain. I don't think I'm going to go and start using PETG for everything just yet, at least not until I get it dialed in. It's got a little mount for the shoulder buttons on the back. Now note this is slightly sort of different shade than the rest of these. I actually have another one printed here in PETG that I printed with the original batch. Interestingly enough though, this is case version 1.2. It's from what you'll find on Thingiverse. And they've made some tweaks to it. The original one was actually screw together, so you needed a bunch more screws for it. And that's kind of cool, but without threaded inserts, eventually the screws aren't going to work anymore. This one is snap fit, so you can just pop it together, and actually that's why I printed it in PETG as opposed to PLA, because snap fit's, at least as Matter Hackers puts it, known for its nice snap fit cases, so I figured that'd be a good thing to try. And I have tried putting this together, it works pretty well. Unfortunately, when they made the change to 1.2, they changed all of these mounting holes to different screw sizes, because before they were these weird SAE units, and now they're all M2.5 5mm length screws, which is nice. That should at least help things. However, the screw holes in the middle here, which is for the shoulder buttons that go on the back, are different. Those are still, they're like basically 2mm, so they're let's see, I have the screws, a number 2-56 by 3/8 inch long. Don't you love non-metric units? So that, I still need that for those, which is fine because the whole thing's a little bit longer when you add that in for the whole width. However, for whatever reason, on the original shoulder mount button, the two of the holes are inset by 0.5 millimeter just towards the center. However, on the case, they're not anymore. So this doesn't actually mate up perfectly. Two of the holes do, the top two do, but the bottom two don't. It actually calls that out in the instructions to make sure you have it the right way. I really wish I knew why they did that, but they've never provided the correct file for this. I think that the 1.2 is relatively new. No, it's from October, so I guess probably just no one's complained about it yet, or they just sort of brute forced it, but I know how to use Fusion 360. So I pulled the original mesh STL from this one into Fusion and quickly designed up this. It took, 5 minutes. And then the reason it's the different color is basically I didn't feel like getting the PETG back out. I already had PLA on from something else, so I just printed in this. Now this, all the holes are the same distance from the center, and hopefully that should work a lot better. So let's see, that's the case parts. The other ones, which are kind of also interesting, which is also new for me, are all of the buttons. Now these are all printed in Ninja Tech Cheetah, so you can see they're pretty pliable. The instructions for this actually do suggest printing them in some sort of flexible material like Ninja Flex. However, my particular printer at this point in time is not capable of doing something that's as soft as a Shure 85A, which is what the Ninja Flex is. But the Cheetah is 95A. It's a little bit harder. It's more like a stiff rubber. It kind of feels like a tire, to be honest, which I've seen people actually use this stuff for doing like legitimate, kind of knobby tires for RC cars and stuff like that. And I figured, it's close enough. The Ninja Flex itself is just a little bit too soft to go through my current extruder setup, but that's okay. So you've got the back shoulder buttons, then we've got the D-pad, the start select, the A, B, X, Y in this case. Now obviously this looks like a Game Boy, but because it has the shoulder buttons and the X, Y buttons, it's actually it runs RetroPie, so it's capable of doing SNES and Game Boy Advanced and other non-Nintendo things. So that's those. So that was kind of cool. The Cheetah works really well. It basically prints with ABS settings. I will note for anyone that cares, I printed some of these with, you can kind of see on the bottom of this one, I printed some of these with Gecko Tech Easy Stick as the build surface. You can see there's still some sort of white bits on there. That is the Easy Stick that got pulled up a little bit. So it liked sticking to this a little too much. I tried various initial Z offsets for the height. They all did it, no matter if I let it cool down or whatnot. However, when I went to go print this one, which is the buttons for the PiTFT screen here, this one I did on my BuildTech Surface, which came out beautifully. It came right, I mean, I wouldn't say it popped right off. I have a flexible build plate system, and obviously if you have a flexible material, it kind of defeats that purpose. So I still had to spudge it off with a spatula, but it did come off without actually ripping up any of the surface itself. So be careful with that if you're doing anything like Ninja Tech Flex or Cheetah. Anyways, so I'm going to assemble all of this now, and we will get started with, I believe, the gamepad, which is this bit. So this is one of the major improvements from the original PiGrrl. You kind of had to wire all the buttons in by themselves directly to the GPIO on the Raspberry Pi. So this connects directly to it and fits right underneath the case. Fits in nicely and gives you a nice option for this. And interestingly enough, they actually do have, if you wanted to just source all these parts, I mean, obviously everything Adafruit does is open source, but they have a link directly to order this off of OSH Park if you wanted to, but they make their own. So yeah, so we'll get rid of all these and I will start doing some assembly. Now, interestingly enough, the instructions point out that you want the notch of this header to point towards the words header on the back of the PCB. If you look at the instructions, it shows having header right out there, but the ones that are in the instructions is very clearly an OSH Park board, whereas this one's not. So it doesn't have that, but just note the the notch there needs to face up towards the rest of the buttons. At least I'm hoping it does. Alright, well, there's the header. Now we need the buttons. Alright, and there's the PCB for the gamepad. Now we can move on to the rest. So, just a note, the instructions still say something about tapping holes, but we're using completely different size screws now. I really wish I knew why they did this, but yeah, it's talking about tapping holes in here, but as you can see, the screws fit nicely through. Yeah, let's see if we can see that. Fit nicely through, no problem, without trying to tap a hole in a piece of PCB, which is just kind of silly. Alright, so I've got those on. So now we need the TFT display, which is right there. Okay, so apparently this one uses GPIO 18 to toggle the LED backlighting on the display, but that GPIO, for whatever reason, it's probably a RetroPie thing, is used for the Y button. So there's this pad right there that can be cut to disable that feature from the LCD itself. So all you need is the, let's see, that's all you need is handy hobby knife, and carefully cut that. Don't cut anything else. I found with stuff like this, it's good to really sort of scratch at it a little bit, and just to really get it all out of there. But obviously we can't go just trusting that that's going to work, so continuity. Let's see. Test that. Nope. Okay, we have successfully, you can see there's a tone there, but this one we successfully disabled that pad. And yes, I do have real test leads. That's just what was hooked up. Okay, so that one's done. Okay, that's all we need to do with the TFT display. So I'm going to put this back in the box for now. Now, this is just weird. We apparently need to cut this down to 108 millimeters, but it's currently 152 millimeters. I shouldn't remove this sticker here. Now it's all really gross and sticky. That's much better. Alright, so it shows that it wants to resize this to 108 millimeters. Get it right there. Alright, 108 millimeters. And in the pictures, it shows it basically as being from the end of the display, or the end of the cable over there. So, just for good measure, pun intended, I'm going to mark this. I'm going to do this again on the other side. Alright, and so we can be sure of where we're cutting, a little bit of tape, also as shown in the instructions. Alright. So, there we go. So now we've got a nice 108 millimeter section, which, was that about measuring twice? So yeah, there we go. Pretty good there. 108 millimeters. Okay. So, I'm going to do something you shouldn't do, which is use scissors to cut this. It's probably going to dull the scissors something crazy, but whatever. Alright, now we've got a cable that I hope I can fix. Alright, so now we need to take the connector from this side and put it onto this cable. So I'm going to see if I can pop this cable open with a small, and I do mean small, flathead. Alright, so there's a couple of clips on here. Should be able to basically just pop right off. They're not going to just suddenly snap and then everything's free. Kind of have to work at it because they're not designed to come apart. Alright, don't you do what I just did and end up breaking that little bit there. That's fun. I don't think it's really going to matter because these should stay in pretty tight. Alright, now we got it off. Mostly intact. Okay. So now we gotta pull this off. Also, carefully because we need to reuse this. I just realized I wanted to make sure I was matching up which side of this cable went with where. So there's a white line along the edge, so those match up. So notch points out on this end. Alright, so that's done. Basically, it's just going to be a matter of placing the cable into the original clip. Probably should take that tape off. So we're going to place that into the original clip and then put the end back on. So obviously make sure everything's flush with the end. I'm going to need a rubber mallet of some sort. Be right back. Alright, now it's on. Sweet. So The instructions do actually note that it's incredibly hard to get this back together. These are obviously, done with a machine in real life, but they're suggested using a rubber mallet or something like that. But if you do have one, I would highly recommend using a vise, not a vise like this. I mean, like a proper workbench vise. I had to gingerly use a 50-pound steel vise to put this on, but the mechanical advantage on it, which could very slowly push from both sides, was definitely a huge advantage. Went on really nicely once I did that. All right. So now on to the amp and the speaker. Okay, so this is the speaker amp. It's a 2.5 watt Class D amplifier. So we're going to wire this up next. So this is interesting. The instructions actually say to use about 9 centimeter pieces of wire for the speaker, and implying that there are no wires on it to begin with. But I mean, this is, we got at least 9 centimeters here. These are already installed, so now we don't need to do that. Again, they need to update their instructions. It's funny, it says to tin these pins at the end, but that's just gonna fill the holes, so I'm gonna ignore that for the time being. Yeah, that's weird. It literally says to remove these wires because they're too short, but they are 9 millimeters or not 9 millimeters, 9 centimeters as noted by as noted by the instructions. So yeah, maybe they changed it. Yeah, apparently these do actually have a positive and negative, but they're not labeled. So this side is positive and this side is negative. I'll label that for my own reference later. So I'm actually using these wires that are from this for pretty much everything I'm wiring up in here, just because a lot of them are already held together, and that way I don't need to like heat shrink stuff back. Sorry. That way I don't need to heat shrink stuff back together. I can keep everything all consistent. Pre-tin these a little bit. Alright, so now we're doing the power switch, which goes in there, and Seems to fit all right. I have a feeling I'm going to be using some hot glue on this later. Also, I'm going to note that in the instructions it shows this without the little holders there for the switch, and it actually is talking about putting this switch all the way through, but in reality it now just sort of fits nicely in there. So again, you know, they need to update their instructions. This is actually a lot better. I like it. I'll probably end up using some hot glue or something to hold it there, I guess. Let's see. So it says to remove one of the legs from the slide switch, secure the switch to the helping hands or to your device, whatever. Apply solder to the two remaining legs. Now we'll use two 30 gauge wires that measure about 7 centimeters in length. Strip and tin the tips of each wire. Okay, and then we're just sort of dead bugging these to the switch. So I'm going to disable one of these wires. Okay, so now this is going to be off. That's going to be on. Take that off. Alright, so I'm going to use, what colors am I going to use now? I'm going to use some purple and gray. That's why. Alright, so it says that we want, how much? We want 7 centimeters. I realize I don't need those. I can actually just get out my ruler. I'm really hoping that all of these wire measurements are actually up to date for the most recent case. Alright, 7 centimeters. So in this case, I'm actually going to split these all the way because I want to be able to put some heat shrink onto this. So do these. So we can tin all the wires. Well, just tin some of them. And I know right now you're probably screaming at me, hey, why are you pushing a soldering iron directly into your desk? Well, this mat that I'm on is made of silicone, so I don't really care. Now that I've done that, I'm going to take a couple small pieces, even smaller pieces of heat shrink, stick them on there just to provide a mechanical strengthening. There we go. Nice and secure. It shouldn't come off. Okay, so now these are going to be wired into the EN or enable and ground pins on the power boost. So that's going to be those two right there. And So since this is just a switch, there's no polarity. Alright, now that we've got that, it is time to hook up the audio on the Pi. Okay, so we need 2 pieces of, let's see, 10 centimeters for the Pi audio. So we'll use, let's see, we'll use some green and blue. So apparently I'm going to be wiring directly to the Raspberry Pi itself, which is really scary, but I'm going to do it. So looking at the instructions now, it's actually what we're doing is wiring directly to some of the pins on the audio jack, which I guess makes sense. That way you're not having to like plug in a cable. So this is just trying to shorten all of that, which, yeah, I get it. It's fine. Okay. But hey, at least I have got lots of spare Pis. Okay, so I'm going to stick this in the vise. So the bottom of the Raspberry Pi, see, they really need to update their docs. This is talking about a Pi 2. On the bottom of the Raspberry Pi, look at the audio jack and inspect the 3 pins connected to the component. What? Take note of the 2 circles highlighting the pins. The left pin blue will connect to the negative pin on the amp, and the great. Okay. And the right pin red connects to the positive pin. The middle pin does not need to be tinned. Disregard the tinning in the photo. Okay, so they've got different pictures, but it's Pi model B versus, or B plus versus 2 and 3. Yeah, this isn't going to be wide enough. Okay, gotta be careful because that's touching connectors. Alright, so what we're going to do is, so I'm also, just for good measure, going to get out my hot glue gun. Well, I guess I'm currently making this Pi no longer RoHS compliant. Get off. So probably one of the reasons why it's saying to add some blobs of solder there is because these boards, I'm assuming, I don't see any markings on it right now, but are RoHS compliant, which means basically no lead, which is a good thing, but man, lead-free solder, it's just terrible. I mean, it's good for the environment. It's terrible to work with, so I don't. I'll wire it in between there. And try to connect that. There we go. That's one of them. A little bit of a blob there is okay. So now I'm going to take the other one. So I'm using these little nubs on the bottom to just sort of hold everything in place, or at least aid in holding everything in the right place. A little bit of tape. And there we go. Bob's your uncle. So these probably would stay on just fine, but I don't like leaving things to chance, and I don't like mechanically insecure things. So I'm going to do this. Just a little dab will do ya. Can't believe I'm actually putting hot glue on a Raspberry Pi. Brand new one at that. But now, there's no real chance of these coming off. Okay. Okay, so now we're going to connect the negative wire to the A- pin on the amp and the positive wire to the A+ pin on the amp. Alright, so blue is negative. That's not too bad there. Alright. Oh, that's the power boost. I'm just going to do these on the bench because it's easier. Speaker. Really need to get some of those helping hand alligator clip things.
Apparently. I don't know. Made it 30 years without them. I'm done.
This is why you don't just do this on the bench. And there she is. Alright. Cut those off. Alright, so I'm going to do the shoulder buttons. Okay, so now we've got all of this wired up, which has got the power switch, the power boost, the audio amplifier, and the speaker, all connected to the Raspberry Pi. And now we need to hook up power to the gamepad, as well as the shoulder buttons. Actually, I'm getting ahead of myself. We need to wire up the shoulder buttons. So this is going to go away for a second. Okay, so fortunately it seems that this came with 3 of these buttons. Probably because we're going to have to sort of partially destroy one. So we're going to clip off 2 of the 4 legs on each button and then use a pair of flat pliers to flatten out the legs so they point outward. Okay, so we're going to first, this pains me to do. Okay, so we're going to clip off a couple legs. So now we will flatten these out. So now we're going to tin a couple of these. Okay, and we need a 4-wire loom in 14 centimeters. So I'm going to use, let's see, hey look, got 4 wires left after all that. So we're going to make this 14 centimeters, roughly. All right. I really don't know how anyone ever does this while the wire or the part is being held by some helping hands. Seems damn near impossible to me. There's one button. Probably should zoom in on that, right? And button number 2. All right, so those are good to go. Okay, so now we need some power cables that are about 14 centimeters in length. So I'm going to sacrifice this cable. Alright, so power is connected there. I think we're good to go on that. And then we're going to connect the shoulder buttons to the gamepad. Okay, so we're going to connect them to this, which, interesting. So we've got left button, right button, ground, ground. So it's not super clear. It would have been nice if they labeled these on here, but apparently it is left, let's see, it's left, right, ground, ground. So it doesn't really matter, it just means I was going to hook up, you know, left and then right, which would not have worked at all. Not in the slightest. So I have to make sure I do that. So we're gonna call browns the ground. And we're gonna call red and yellow the rest of it. So let's see. Alright, so we've got the shoulder buttons all hooked up. And yes, they're crossed over. But that's okay, because basically we've got now the yellow is the left and the red wire button is the right. And the other two are grounds. And now we need to connect the gamepad to the power boost. So solder the 2 wires connected to the power pins of the gamepad PCB to the power output of the power boost. The 5-volt wire from the gamepad connects to the positive pin. Oh yeah, obviously. So, sorry, the obvious. Okay, it's interesting that everything's kind of powered through here, but you know, hey, why not? This is a little bit crazy, but hey. So, we've got Raspberry Pi, the amplifier, speaker, power boost, gamepad, and the shoulder buttons. So now it wants me to power this up and test all the things. Alright, so that seems to work fine. I need to load some ROMs on there, but we'll play with it in a little bit. So now we're going to mount everything in here. So, okay. So we've got the case back. I'm going to actually take the TFT screen off, if I can. Alright, great. If I can get it off. Okay, I would not have put that on there if I had known it was going to be such a pain in the butt to get it back off. Alright, so I'm going to lay out a piece of paper just to protect the screen. Alright. Alright, so we're going to put in the buttons first. So in go the buttons. Cool. Alright, that seems to fit pretty well. So again, the instructions are basically, well, kind of wrong, because apparently they've updated everything to using these 5mm long M2.5 screws, which is preferable because English units are for suckers. So let's see if we can find the screwdriver tip that works for these. Alright, so now that's in. Okay, so now we're going to install the game PCB. Just going to put the buttons, oh no, that's the wrong buttons. Put the buttons in first. Alright, I'm not going to try to take this out again because I already had enough trouble doing that. Annoyingly, I can't lay this flat because it pushes the buttons up, which pushes the gamepad up. Oh well. Hey, look at that. That's nice. Okay. Now we're going to connect the cable, which is slightly off kilter, but that's okay. Okay, so we're going to put the speaker, so we lay the speaker over the cavity with the grill and press down to snap in place. The wire should be oriented in position so it's not in the way of the corner standoff. The corner standoff, which doesn't exist anymore. Okay, so that's what I was afraid of. So snap fits in there a little bit, but it's not great. So I'm going to use a little dab. Okay, so now we need the shoulder button mount. So we need to mount our 2 solder buttons to the shoulder mounting piece. Use E600 hot glue. And again, if we recall, the yellow is the left, which means the yellow needs to go on this side. I guess that's left. I can always remap it. So I need to actually kind of turn these around a little bit. Alright, I'm going to use a little dab of hot glue on that. Okay. And a little bit on that one. I always say a little bit, and it always ends up being probably way more than need be. Alright, I'm going to resist the urge right now to put some hot glue over those. They're probably fine. Okay, so this is where it gets weird that I need apparently some different screws because the mounting on these is all wonky. Alright, so again, remember this is my custom made one. Yeah, don't do that. Hey, look at that. My modified version actually matches up with it. And I should probably remember to put this in first. That would be bad if I didn't. Alrighty. The rubber buttons are getting in the way of being able to put this on flush, so I'm just putting it between these 2 boxes to provide a little bit of a gap. Something to rest the rest of the case flush onto. Well, I made my first mistake, which was I should not have put these all the way through, because now I got some holes in the back. Well, I screwed that up. Not the end of the world. Just longer than I thought they'd be. Oh well. Let's Instructions said fasten them all the way. They were wrong. Okay. So, now I'm going to install the switch. Again, they say that this is probably fine. However, hot glue. I'm going to mount. This is a rat's nest. So annoyingly, it would seem that some of these cables kind of got all up in each other's way. Yep, apparently I should have thought about where the cables were being run. Because now I got cables all wrapped around themselves. Okay, so the screws for the soundboard don't fit. I'm going to have to fall back to the other screws. Hope that these work. Alright, now to install the battery. Nope. Turn off, turn off. Okay. So yeah, getting this battery in here is going to be a royal pain in the butt. To say to use a battery that's this big, at the same point, the battery doesn't fit. Urgh. Righty. Alright, so I think I got the battery in there. Maybe. Question is, will the Pi go back in? Sort of. Kind of. Almost. I'm not sure. Let's see if it'll close up. Don't be a pain. Alright. Apparently, you have to take the SD card back out before you close it all up. Hey, look at that. I got it closed. Nice. Alright, so SD card goes back in, and moment of truth. Oh, yes. Seems to take a little while to boot up though. There we go. RetroPie. Not sure you can see that. Sounds a little weird. I think it's still saying it's like a PCM device. Alright, there we go. I'm just going to load it up with some ROMs, which I will do later, but that's the build. Not too bad. Except for a few weird things. The fact that it makes a really weird sound. Alright, so it's actually a couple, 2 or 3 weeks after I initially did this assembly, and I've got it all working now. I've got some ROMs on here. You can see that I've got Super Nintendo, arcade MAME games, Atari, Game Boy Color, Sega, Sega Mega Drive, which I guess is the Sega Genesis, Neo Geo, and some Nintendo stuff. So I was able to load those all on there. It worked pretty well. Actually, not pretty well. It worked really, really well. Just kind of, show some. Well, here we'll do some classic Super Mario Brothers 3, and it kind of goes back to the little text thing for a second, and then loads everything right up. I've only run into maybe 1 or 2 that didn't actually load out of probably the 1,000 or so ROMs that I've got on here. So yeah, it works really well. The screen's pretty good. I think it's a 320 by 240 screen, which, I mean, oh, man. I can't talk and play this game at the same time, despite the fact that I'm terrible anyways. I think it's a 320 by 240 screen, which is fine, because that's higher resolution than what these older consoles were anyways. I kind of have some thoughts for changes were I to make my own one of these, which I'll get into in a second. So the major things that I ended up running into, as you probably noticed earlier in the video, it was really, really hard to kind of get this all back together. It was a bit of a rat's nest, and then the battery didn't really fit in a great place. And they said to use a 2500 milliamp hour battery, but that was just kind of a tight squeeze. So one thing that I found later was the fact that there's a bit of a sound issue with these, and it really comes down to shielding. Now, I'm not even sure if this even shows up. I'll try to get it closer to the camera. You should hopefully be able to hear the sound. So you can hear it a bit. The problem is, and the reason why it's so low is that I had to turn the gain on that audio amplifier way, way down, because there's a bit of an issue with the fact that this uses SPI for the screen, and by default it's set to 80 megahertz, which is just ridiculous. Now that enables it to do 60 frames per second or whatever, but it's there I go again, talking and playing. It's possible to do that same frame rate down to, I think, 48 or maybe even 36 megahertz. And what was happening was basically every time the screen was refreshing, it would cause this crazy high frequency squeal on the speaker. At first I thought it was just me, but then after a lot of many hours on various forums, including Adafruit's, it turned out that it was sort of just a problem with this kit. The only way that I could avoid it completely was to move the battery. But unfortunately there's only one place to put the battery. It was literally like I had the case cracked open and the battery was just hanging out to the side, and then I got no weird feedback, noise, or anything. And the reason for all of that is the fact that this is completely portable, obviously, and there's not enough shielding and there's not enough filtering on it, so there's a ground loop in it. If you've ever had now cars are all Bluetooth and whatnot to your phone, but sort of back in the day where you'd be charging a phone and listening to music from it over a auxiliary input line import to your car, it would create what's called a ground loop, because there's no ground to actual earth. So, and I'll put a link down in the description that kind of explains that a little bit better than I'm doing now, but that can cause some feedback, and as well as the fact that we've got a very high frequency data signal going on in here. When the battery was between the TFT board and the Pi, it was picking up on that, and I went through all sorts of things. I literally, and it's still like this right now, the battery is wrapped in a layer of Kapton tape, aluminum foil to which a grounding wire is soldered to, and then that's soldered to the ground of the boost circuit in here, and then wrapped again in electrical tape so that nothing shorts out on that, and then shoved back in there, and that helped a little bit. The major thing that ended up working was I decreased the SPI to I think 36 megahertz. I will include all the details for how to do that in the description as well. And I also turn the gain on the amplifier way down. So I mean, right now this is at full volume, which is fine for me. If I were to do this myself, I would have ditched the speaker entirely and just gone with a headphone jack. Just use headphones for whatever I need. I don't need this making noise, and actually I prefer it not to. Like if I was going to use this around, I would just turn the sound off. But it'd be nice to have the headphones on there. I mean, I've got a Pi 3 in here, so in theory, this could work with like Bluetooth headphones, but I'm not sure how RetroPie handles that. And the Pi itself does have a headphone style jack, but through some further research, I also found that that's not really. I mean, it would work with headphones, but it'd be very quiet because it's a line level output, which is just a solid 0 to 1 volt reference level. That's basically, it's meant for plugging into something that's then amplified. So you're really not going to get any real volume out of that on headphones. You would need some external amp or DAC or something like that to boost that, which I'm not sure that would fit in here. I may or may not embark on a project to do sort of my own version of this with a better screen that doesn't have that feedback issue and with just a headphone out instead of the speaker and some other things. But, you know, that may or may not happen just depending upon time. It's just sort of as I went through this, I got thinking about, you know, what I would obviously change on it, because it's a complete mess in here, and getting rid of that, the audio or the speaker output would get rid of a whole circuit board in there, and just there's a bunch of ways to possibly clean this up to, I think, make it a little bit neater. One that I'm actually toying with, if I was to do this myself, is I found one of these. This is from company 8-Bit Do or 8-Bit Do or however you pronounce it. They make a lot of really high quality sort of retro style gamepads, and I found this is a Zero. It was, I think, $12 on Amazon. Now obviously this isn't a wired connection to whatever you're using, it's just Bluetooth, but again, like I noted, I used a Pi 3 in here which has Bluetooth. RetroPie supports it. So, and if you look, it's roughly about the same size. It's actually a little bit smaller, which is okay. It's a little bit narrower than the default one on here. I kind of thought about playing with that and taking the board out of this and then just basically mounting it behind the same thing and using that instead. I don't know. It's just something I may play with in the distant or not too distant future. We'll see. But other than that, I mean, other than the sound issue that I ran into, it works really, really well. So we can pull up some other ones on here. So the arcade games are kind of cool to see working. Although obviously and this is one of the reasons why I kind of would do a different screen. A lot of the games are not really, like for arcade, are obviously designed for like different aspect ratio screens. Let's see if this loads. So you can see, yeah, a lot of, I mean, this is basically a 4x3 turned sideways into sort of portrait mode. So everything kind of gets, you got these big black bars on the side. I mean, there's nothing I can do about that. It's just that it makes it really, really hard to read because the screen's so small. All in all, I'm quite impressed with this. I have spent far too much time playing Tetris on it. Not this Tetris 2 junk. It's kind of nice to be able to just sort of load these up. For the Raspberry Pi, I really, really wish that they would include headers for a physical shutdown and restart button. Basically just like you'd have on any computer. You know, I mean, you can, even if you have to configure it in software, like what happens when you hit that button. Because right now, what you have to do with this is go into the menu and scroll down to quit, and then go to shut down the system, and then shut down, and then it goes to, it's kind of weird to see a Game Boy style device with, this Linux console spew on it. But then now that it's here, now I can flip the switch and turn it off. Obviously a normal game console, you pretty much can just turn it off and nothing happens. But at the very least, it would be nice if you could just like basically push a button and it would power itself down. But that's not the fault of Adafruit or the way that they made this. That's purely that there's no real easy capability for that on the Pi itself. So I'm kind of hoping that one day there'll be a Pi 4 that'll have just a nice, you know, like 3 pins, ground, reset, and shut down. Or, well, reset and basically power, which would do both, you know, turn it on, turn it off. So yeah, this worked out great. I would definitely, you know, recommend it for people if you like this sort of thing. I've had so many friends see this and immediately want one. Yeah, that's the entirety of the Adafruit PiGrrl 2. Hope you enjoyed it, and thanks for watching. Bye.